Okay, so which is the condition we need here?
If A is greater than B.
Okay, if A is greater than B, we do something, otherwise else we do something else. Okay, what is new now is that what have we to do in case A is larger than B? If A is larger than B, is greater than B, we have to return A. Return means stop the function and give back a result. This expression here is what is in place of the function call. So you can imagine what we need here. What do we do in line 8?
We return B.
Return B, obviously. Great. Well, now we can try to execute this program here. I just run. Okay, I should save it. Let's save it somewhere. And let's go just in the desktop. I'm not so new folder file, and we call this f.py. It's our first function. If I run this program, oh, there is no print here, so nothing happened. So let's print something. Print Z and print T. So if we run this, we get 45 as a first result. Why is it 45? Because we get X and Y, they're 45 and 23. So this time A is 45 and B is 23. And the return value is the value in A. The second time we have 68, and that's easy because X plus Y is 68. So this time A is another number and B is another number. So what's interesting is that if we debug, and that's very interesting to see what's happening, if we execute this program step by step, which is the first statement? The first statement is this def statement. And what's in the def statement is all we see that is aligned to the right. So from line 2 to line 8. Line 12 is out of the definition because it is aligned in the first column, as in the while statement, as in the if statement. Okay, so the first statement is defining a function. If I execute this statement, what we see, look at the right here, is that we have a new name that is the name of this function. So the Python interpreter knows that max value is a function. So we created a new function. Go ahead, assignment, so 45, and so we created variable X. Again, we created variable Y, and that's the interesting part. We have to compute, to evaluate the right part of the assignment. The right part is a function call. So the expression we see in Z equal to something, the expression to the right is a call to function max value. And the first parameter is the value 45, and the second parameter is the value 23. So go ahead, and what happens now is that we are stopping, we are freezing this program, and we are calling function max value. And this program is just waiting for max value to finish his job. So we stop here, we call, and that's very nice looking into the debugger, because we see very clearly that this background window is the execution of the main program, and we are executing now, waiting for max value to do its job. And look here in the lower part of this new window that variable A takes the value of the first parameter in the call, and variable B, so the first parameter is A, the second parameter is B, and they get the values of the first and the second expression in the function call that were X and Y containing 45 and 23. So we have two new variables, A and B, that start as if we assigned 45 and 23. Okay, the rest is easy. Okay, this is just a comment. Then we get to the if statement. The condition is A compared with B. The values are these, so the condition is true. And we go to return. When we go to return, we stop and say, okay, the result is A, that is 45, and we stop executing this function. So what you will see now is that this new window just disappears, and we go back to the main program. And the result is 45. Okay, go ahead. A new function call. We first compute which is the first value, the second value, and we again freeze, just suspend executing this program, and we go to execute the function. But what are the values in A and B now? We have different numbers. A is another number and B is another number. And we go ahead as before. We go to the if statement. We compare these two values. This is still true as before. And we go to the return statement. Return means, okay, we finished. We go back to the main program, and the result is 68. So what we do now is assign to variable t this other value. Okay, any question? Okay, after that we have the print, one print, another print, and no problem. Okay, so what's important is that we define a function, and after that we can use a function. Well, let's try to write all together. Let's try to write a new function that what can we do? Imagine we have two numbers, or better, we have yes, two numbers again, and we want to we call it compute difference, for example. Compute diff. Can we call again A and B the two parameters? We can, because this is a function, and A and B are called local variables. Local mean that we can only use A and B here. And this is another function, and we can use the same names, and we again have A and B that are local variables, and they are just used to get the values in the function call. Okay, what should we do here? Let's write some comment. Returns the difference between. This is very easy. We don't need a function to do this, but we are learning how to define functions. Numbers. Okay, what should we write here? We don't have to take any decision. We get two numbers, A and B, which is the result. Are you there?
So return A minus B.
Okay, perfect. So we can just write return A minus B, or if you prefer, but it's exactly the same, I can also define another value, another variable, and compute A and B, A minus B there, and then we return B. It's exactly the same, but I do like the first way of doing it, A minus B. Okay, but what if we want to write a different function, compute absolute difference? So return the difference between the largest of these two numbers. Okay, what can we do instead here? That's not right. What should we do here?
So we do the same as we did before with the maximum value. So we write if A is greater than B,
Agree?
return A minus B.
But be
Else,
careful that this must be to the right because we are into the if.
yes.
Perfect. And
Then we
then
write
else.
else return B minus A.
Okay, great. So if we try to write here print compute absolute difference among x and y. Okay, let's get rid of this. We don't need this again. So we are defining two functions, and we are not using the first one. We are only using the second one. And if we perform this, we get the difference is 22. Okay, great. And it also works if this is 203, and it said that the difference is 158. Okay, great. We can define as many functions as we like, and we can use some of the functions. When we write in the head of this program, import math, it's just as if we are defining all the functions that are already defined in math. So what's in math? It's just a large number of definitions, of function definitions. So if we import math, it is exactly as if we define a lot of functions that are already, but we get the already available definitions. Okay, great. Did we, so we saw list, if I'm not wrong, before Christmas. So we are able to define something that is our sequence. Okay, are we able to work with this kind of variables? Is it? Am I right? Okay. So I want to define a function here, and I say that the parameter is expected to be a sequence, a list, for example, and this prints each item in sequence, one for each line. Okay, are we able to do this? If I write just here print sequence, what does it happen? And here I call printing column. Okay, what's happening here? I have this list into this variable. I call this function. This function has sequence that is just this list here, and then just prints the sequence. If I do this, I have just a print in this way. I don't want this. I want one item for each line. How can I do it? We must execute one print for each element in the list. So are we able to do this? Hi there. We need a loop, a cycle. So what we did last time is take a variable while this variable is smaller than len of sequence. We already know how to do this, but we know that sequence is the list we are dealing with. So while I is less than this, we can print the element in position I, and then stop. We just write return because this function has no result to give back. And in fact, when we call print, we don't expect to have a result. We don't write something like a equal to the result of this function. When we do this, we just stop executing this program and go here. We give this sequence to the function and we print one element at a time. When this is done, this has been done, we just finish. And we don't have a result. So there are some functions that take arguments and return values. And there are also functions that do not take arguments and return values. And there are functions like this one that take arguments and do not return anything. Just do some job, but don't return the result. Actually, we already use the print function. When we use the print function, this is just a function. We give this value, don't have a result, but we see that value on the screen. Okay, does it work? Perfect. What's the problem here? What's happening?
There's an
Stop.
infinite loop.
Infinite loop. Why?
We
We're
need
always
to make I bigger.
yes, we are always printing the 0 element, 45. So we forgot to increment I by 1, and this time it should work properly. Obviously, if I do the same with another function, with another list, and we pass here another sequence, this is a value, a list. This is another value, another list. We will see this printed and then this printed. Okay. Oh, we do like having space. So let's do it one time. Let's have here a print, or better at the end. Before leaving the function, just print an empty line. And it will behave a bit differently. We make just one change and we have a different behavior here and a different behavior here. We define one time We change one time and we use many times. Okay. Now let's just stop for a while and let's concentrate on this problem. We have to scan. We are just scanning a list, starting from some position, checking whether we are at the end and increasing the position. And this is a very common template when we are using sequences. Be careful in how in our mind I is a position. We are using this variable as a value that have to tell us in which position we are working. But actually, there is a different way of writing a cycle when we are dealing with a cycle. And the different way I would like to look at this and I want to show you in the same program that, okay, I will comment this. So let's put this symbol in front, and let's use a different way. This is another cycle statement, the for loop. The for loop has a very simple syntax that is a variable here, then in, and a sequence, and the sequence here. And as in the while loop, we have then moving to the right, we are moving to the right, and we are writing the body of the loop. The meaning is that variable, we have to choose a name for that variable, is one element of the sequence at a time. So the for loop is written in this way, means take the first element and the name is this. Take the second element and the name is this. Then the third element and so on. And it automatically starts from the first element and ends with the last element. So the same cycle where we have written in this way by using a variable for controlling the position is much easier to be written in this way. Let's write, let's use a nice name for the elements. Let's call it element. And this is just sequence. So the list we have here. And what we have to do here is just print element. This is exactly the same behavior as what we have written before. We don't need positions. We are just dealing with one element at a time of the sequence. And from in some sense, it's much simpler. It works in the same way. I'm pressing the green button. I clear here. I am executing this one, and it's very easy to be written. Okay. So imagine we want to do something different. Print each item in sequence, one for each line, including its position. So what I want to have as an output is a 0, and then what is in the position 0, then 1, and what's in position in 1, then 2, and what's in position 2, and so on. Okay. Can we do it in this way? When we are executing the for cycle, we don't know which position we are observing. But while in this way, we know that we have a variable that is the position, and then we use it as a position. Okay, so we can say that if we want this result, it would be much better to use the while loop instead of the for loop. But let's look again at the for loop. Let's go here. What does it mean? What do you imagine is happening now? The for loop takes this variable, and this variable is one element of the sequence, one at a time, the first, the second, and so on. So what is C here?
The second element. Actually, I mean number 2, but it's the
no. Don't. Okay, that's important to see that. What is this C? This is a variable name, and this is a string of characters. So this
okay.
C doesn't have anything to do with this item here. This is a variable, a name of the of variable. It's like as if I write here John, or I write here John. This is a variable name. This is a string. Okay?
Yes. Okay.
Perfect. That's important. So your answer was very important. Your question. So what is C? What happens?
It will give error, I guess.
It's not an error. Look down. What's happening?
It goes to a string.
Yeah. So C, why? C is just as before. C is one element at a time of A, B, C, D, E, and so on. So we can, when we write for, let's use element, or let's use a variable in sequence, we are always doing the same thing. X is the first element, the second element of this object here. So we can have, what can we have here? We can have a list, we can have a string, we can have anything that can be seen as a sequence, and many other animals can stay there. So when we wrote this, yes, if this is a string, this is one element. This is one element of the string of the list. Sorry, this is a list. This is a list. Let's try if I write print in column. And I pass a string, What's happening in this way? It happens that sequence this time is this string, and we get one element at a time of that string. Okay? That's it. The for loop is very useful. We can use in many different ways. We can put almost anything that can be seen as a sequence there. And there is a very useful sequence that is range of a number. This is the sequence 0, 1, 2, up to, which is the last element, range. This is a new word, range and the number. This gives us a sequence of integer numbers from 0 to 9 or to 10. Guess?
10?
To 9, I
No.
think. Because
start
there are
from-
10
we always-
numbers from 0 to 9.
Yes, we always start from 0, so we stop one element, one value before the end. These are 10 elements from 0 to 9. Well, this is just a comment, obviously. So if I print, what happens if I print X? Let's get rid of this. We print the numbers from 0 to 9. Okay? Well, so let's go back here. Okay, we don't like this while loop. We want to print this. I use a for again. Let's clear everything here. Now look at this print. For P in range of something. Here I want to generate all positions of sequence. We have this sequence to print. How can we generate all position? For P in range of something. Remember, range of something generates the sequence of values. Which values do we need here? All the valid positions for this variable, for this list here, or whatever it is. Range of what? How many elements are there here?
10 of sequence?
Len, yes, perfect. Len of sequence. This generates all the positions of sequence. P, I call it P because it is a position. And then we print. What do we print now? I want to print this. I want to print 0, 1, 2, and anytime I want to print the position and the value. So we print P, and then sequence of P. Okay? Can you imagine what's happening? In the first iteration, P is 0, and we print 0 and the 0 element, so the head element. Then P is 1, and we print 1 and the element in position 1, 2, and so on, up to the last element. And we stop just before length. Remember that length of sequence is 10 if positions are from 0 to 9. And we get almost what we wanted. Okay? So, if we want to scan a sequence, we have just two ways. We have two ways. Either scan elements, that means write for whatever you like, element in sec, and you use the variable ln. And ln, what we know here is ln is one of the items in sec. The other way is scanning positions. So for, and I call it differently, I call it I, P, usually I is an index. In range, remember range for generating all these numbers, and the length of sec. And here we can use sec of in position I, and we also can use I. So this is more powerful. This is simpler. But when we are in the body of the loop, we don't know in which iteration we are working. If it is the first or second, we don't know. While if we use this way of scanning positions instead of elements, we know where we are. We know that we are in position I. So we can do something more. This is simpler. This is more powerful. Well, now let's try to deal with let's start with a simpler problem, that is this. Obviously, this function already exists. Total sum of the sequence. Return the sum of all elements in sec. Okay. Imagine a sequence. Imagine we have a sequence numbers. How can we compute the sum of all the elements?
To store the sum in a variable and going through the sequence, and every time we take a number, we add to the sum.
Okay, perfect. And when we are looking at the numbers, are we interested in which is the position or not?
It doesn't matter, but it's important to take all the positions.
Okay, so it doesn't matter. When we are looking at a number, we just have to add that number. And we don't care about the fact that this is the first, the second, the third. So we can use the simpler way. We just scan elements. We don't need to scan positions. We just scan elements. So we have this total starting from 0, and then we use the for loop instead of the while, number in sec. This is a variable, we choose the name, but it's important that we use a name that makes we understand that this is not a position, this is a value. And we just sum up in total. Okay, and what do we do at the end? We are done. So at this time, sorry, when we are writing a for loop, all statements that are to the right into the loop, but these statements are out of the loop. So the indentation is important. This is into the loop, So this is performed many times. And this is performed one time at the end. Okay? So we do this and this and this and this. And when we are done, then we go ahead with the next statements. Well, so what do we have to do now? Remember to return.
Return the sum, the total.
The total, yes, perfect. And we try to use that now. We have x, that is, we put here 10, 20, 30, and we print total sum. So we call total sum, we give x to the function, we get back a result, and we print that value. Okay? If we choose nice names, this seems to be English, print total sum. And first of all, we see that it works. It is 60, okay? And I want to put one question. What happens in this way? I just moved the return statement to the right. What does it mean?
It only returns the first sum.
Sorry?
It only returns the first element.
Yes, only return the first element, because in the first iteration, I do this. In the first iteration, I have the return. Return means the function ends, stopped, has finished. So total is 0. Then we add the first element, the element in position 0, and we done, return. So what should we see in the print? Just 10. Okay, is it clear for everybody? In this way, it's correct. And what if I do this? Return.
Nothing happens.
Yes, actually there is a special value that is called none. Can you see here? It's called none. This doesn't return anything. Actually, it computes the sum, then it finish and doesn't return an empty. This is called the void function, an empty function, a function that doesn't return anything. Actually, we can also omit the return, and it's wrong. Actually, it's not wrong. It can be executed, but it doesn't do what we want to do. Okay. Obviously, we already have this function. If I write here just sum of the sequence 3, 4, 2, the sum function is exactly what we wrote before. This is a built-in function in Python. And we also had the max function. If I write here max of something, and this is still a sequence, max of John and Marcus. What does it happen here? It returns the maximum value. We can compare strings, so we can compare it them all, and the maximum is this. Do you think you will be able to write a function like this? How can we find the maximum in a sequence?
Seeing the number of elements.
We know we have the length of the sequence is the number of elements. When we have to do something like this, just think about how you could solve the same problem by hand. Forget about the computer. I give you a sequence of 20 numbers. 20, because if they are 3 numbers, you just look at the numbers and give the answer. If they are 20, you have to think about it. If you have 20 numbers on a piece of paper, how can you find the maximum? That's what we call an algorithm.
We check all the numbers and we compare them with a variable that we
compare them with which number? We are only able to compare 2 numbers. This is the basic operation. I am only able to take 2 numbers and check which is larger.
and the one that is larger, we will compare that with the next number in the sequence, and so on until the sequence is over.
Okay. So in the meanwhile, you have to remember which is the largest value you observed up to now. When you're looking at 20 numbers, you see the first one, and you say, okay, the first one is okay for me. Then you look at the second, and we have to decide. Do we still have the first in hand, or we take the second? It depends upon which is the largest one. And if the second is largest, we forget about the first and we take the second. Okay? Now we look at the next one, and we compare it with which the best we have in hand. Okay? So let's try to write a function like this, def maxval. I call it maxval because I don't want to confuse it with the max. And this is a sequence. What can we do here? First, returns the maximum in sec. I will show you why I always write this kind of a comment. That's very important. In the first line, I go to the right and I write a string. And we will see later what happens. Okay, how do we work? Sooner or later, we will do return something. Okay? So we say, first of all, we have a variable for keeping in mind which is the best value we have seen up to now. Let's call it current maximum. And what does it happen at the start? What is the current maximum?
0.
You say 0. Okay. And
Or,
now I
or
write
the first element of the sequence.
If I give you this sequence and you start by 0, what happens? This is not best than 0. This is not better than 0. This is not better than 0. The maximum is 0. Is it correct?
Yes. So we take the first number of the sequence, the first element of the sequence.
The first element. Which is the first element?
0. I mean the 0 position.
0. The element in position 0. So this element here. We take this value, that is the element in position 0, and we copy that value into this other variable. And then we start looking at all the values. Okay, the same question as before. Are we interested in elements or are we interested in positions? We have to look at all the values. Do we care about we are now looking at the 5th or the 6th or the 7th element?
We only care about the elements, not the positions.
Yeah, perfect. So element in sec. And what we do here? We are
You put an
into.
if statement.
We have an if. Either we preserve the current maximum, or in some other case, we modify the current maximum. Why?
The thing that is necessary to change our mind of the maximum is when we find something higher.
Okay, so we are
So we need
looking
to
at this value here. Perfect. If it is larger than current maximum, if this is larger, we change our mind. Okay, you're right. What do we do here?
we change our current max to that element that is higher than our last.
Okay. So we change that value, and what do we store into current maximum? This is an assignment. This means take this value here and copy into this variable. And the value we are taking is just ln. We are looking at this value. If this is larger than the current maximum, okay, we update. Otherwise, we do nothing. If the new element is smaller, we don't do anything. We go to the next. Okay, so there is not any else. There is not else here. We don't need the else. Okay. Well, return what?
Our current max element.
Yeah. Okay, it's very nice to look at the behavior of this program. So let's just save, and we were in shield. Okay, scanning .py doesn't matter. And first of all, I want a good example. Let's imagine that we have 4 here, then we have 5, we have 3, we have 2, we have 7, and we have 2 again. And we call maxval. So we are calling maxval, we are giving to maxval this sequence here, and it returns the current the maximum of the sequence. Save. Let's try to execute this, and we get 7. Okay? Is it correct? It seems so, yes. But let's try to debug one statement at a time. First, we are defining this function. Okay. Then we are defining this function. Okay. Defining a function means that it will never be executed unless there is some call to that function. So in this case, we are defining 2 functions. Well, we are never calling the first. We will call the second one. So what is perform this? Defining a function, and then perform line 16 and line 17. Line 16, it's a bit long, so we step over. And look at the right. What do we have at the right? We have this function, and this sequence here, x. And then we go into the print function. We will call the print function, but first we will call the maxval. So we take this sequence, we call maxval, and we freeze this program, and we go here. And we are set. Now we are set this list here. And it will be nice to try to understand what's happening here. So I am always pressing this button here. Current maximum. We take the element in position 0, that is 4. And we have the current max variable that contains 4. Then we are scanning this. The first element is 4. Oh, that's a bit strange. We are looking at the first element. Is it a problem? We say the first element is the maximum, and then we look again the first element to check whether it is better than the maximum. Okay, nothing happens in this case. We are taking the value is 4 here. The current maximum is 4. Is it better? False. So we don't do anything and we go to the next one. So the next element is number 5. We compare with 4. This is true. And so we go to update this variable. So we take 5 and put it into current maximum. And you see here the current maximum has changed and it's 5 now. Let's go ahead. Next element, we are in position 2. We take number 3. Okay, the element is 3. The current maximum is still 5. False. And we don't do anything and go ahead. Okay, is it clear? So step out, we go up to the end, and we will print, and the result will be 7. Okay. Obviously, we are solving very simple problems now, but we will do something a bit more interesting in a while. But what's important is that we know how to scan a sequence and we know how to define a function. And look here. Remember that we had the help function to have some information from the interpreter. What if I write help max value? Oh, sorry. First I have to run this. Max value, not max value. What do we see here? This is just the string we wrote here. This is called a documentation string. And it's very interesting to have this because, for example, if I import math and then I write help math.sqrt, we see something. And we see this because when this function has been defined, something has been written there. So anytime we define a function, we take a few seconds to write some documentation. Which are the parameters and which is the return value, if it turns out something. Okay. A final exercise on this, always in the same we still have a sequence, and we have to return true. This function returns true if sec is increasing in increasing order and false otherwise. Okay, are we able to do this? First, is there any special case? Simple case.
When sequence has just one element?
Yeah, in that case, what can we say? Is it in increasing order? Yes or not?
Yes.
Yes. So let's write it in Python. It's very easy. So how can I recognize whether it has only one element?
Length is 1.
Len sec. How can we compare this value with 1? Double equal, remember? What do we do in this case? Return. We are done. Return what? False or true? It's in increasing order. But I will say less or equal than 1. Also, if it is 0. If we have no elements, okay, we can say it is increasing. Okay, you say a sequence with no elements is not a sequence. Actually, it is a sequence with 0 length and no elements. Okay, can I write here? Or should I write an else? If the condition is true, return, and the function has finished its job. Return means stop the function and go back. So if the condition is true, we do this, and we will never do anything else. If the condition is false, we will go here. So we go here only when condition is false. Because if the condition is true, we go here, and we will never go to the next line. This is a return. There is a return there. So what do we do in this case? That's a bit hard. Again, imagine you are solving this problem by hand. I give you a sequence of numbers. Look at the numbers. What do you do? I'm using this as a blackboard. We have this. Is it increasing or not?
No,
Okay, why?
because we have a smaller number between two higher numbers.
No, not between two higher numbers. We could also have 3 here. So which is the problem? You are close to the answer. Why is it not increasing? It is simpler.
There is a number after which there is a number smaller than it.
Okay, so this is the problem, no? This is the problem. So as soon as we see something like this, we say no. Okay? So what are you doing? You look at these 2 values, and you say, okay, by now, it is okay by now. I don't know whether it is increasing, but it seems to be, it could be increasing. Let's try something simpler here, sorry. Let's try 2 here, then 23, and then this, and then this. Okay, so we look at these 2, and this is okay. Then, which is the next check we do?
We check whether 23 is less than 130.
Okay, and this is okay. Then,
We do the same with 130 and 3.
okay, and we say no, we can stop. What do we do? What do we say? Which is the result in this case? True or false?
False.
False. And we stop. We don't care about the rest. Okay? Imagine this was 300. We look at this. Okay, go ahead. Go ahead. Go ahead. Hop. Go ahead again. No, it's not okay. Stop. False. But what if we check this? We say, that's okay. That's okay. That's okay. That's okay. That's okay. The sequence is ended, is finished, so we can say true. This is increasing. Well, so are we able to write what we have to do? Compare each element with the next element. And what do we do? If they are okay, go ahead. Otherwise, stop. False. Return false. Okay, this is only a special case, line 3 and 4. Well, do we need positions or do we need only elements of the sequence?
Positions.
If I write for lm in sec, okay, and then I compare lm less or larger what? We don't know which is the next one. So for I in, remember, range, it's always the same, range of len or something. This is the most common Python writing, for I in range of len or something. And what do we do here? Remember that I starts from 0. Then we go to 1, 2, 3, and so on. What do we compare here?
The element from position I with the element from position I plus 1.
Great. And what do we ask?
We ask whether is greater because we want to have the case in which we stop.
Okay, if it is too large, it means that we are looking at something like this. If it is larger than the next, we can say stop. If it is this case, we don't do anything. We say, okay, go ahead. So if it is larger, then we can stop. Return means we don't do anything else. The result is false. Otherwise,
Don't do anything.
don't do anything. Okay, but when, so we go to the next element, check, next element, check, next element, check, next position, sorry. And when do we say true? When do we say, okay, it is okay, the sequence is increasing? If it is the case, go ahead, go ahead. This is not good, false. But if this is the case, go ahead, okay, go ahead, okay, go ahead, okay, go ahead, okay, go ahead, stop, finished. What can we say now? True, increasing. So if we can, we do this when in case we reach the end of the sequence. If we never do this, it means that we really scan all the elements and we can say true. Okay? It is close to be correct. Let us try. Take this and take this. And print, which is the name of the function, is sorted. This will print either true or false. And then we will try on y instead of x. Okay? Okay, we still have these functions, but we will never use these functions. We only use the is sorted. Run, and look at the result. We see false, okay? It means that we called is sorted on sequence X, and the result is false, so the print gives false. Then in line 29, and you see here that we are in line 29, we are calling function in line 29, this one, we are calling function is sorted, and in line 7, we have a problem. The problem is list index out of range. In this line, line 7. Why? List index out of range means that somewhere we are using a position that is out of the correct positions for that sequence. Why? What's happening?
At the last step, when we compare sequence of I with the sequence of I plus 1, we compare in our case. Can you please show us the why?
When we look at the last elements, they're correct. When we are looking at the last elements, okay, in the first case, it doesn't matter because that's okay, and we stop here. But in this other case, that's okay. I plus 1, I plus 1, I plus 1, I plus 1, I plus 1 doesn't exist. So we cannot, when we say compare each element with the next element, this is not correct. We cannot compare each element with the next element because the last element doesn't have a next element. So which is the solution? I doesn't have to go up to len minus 1 because in this case we are going from 0 to len minus 1. And when I is len minus 1, this is the last element. The position len minus 1 is the last one. And this is an element that doesn't exist. We had to stop a bit earlier. We had to stop here in len minus 2, not in len minus 1. So we stop here, and this is the next element. And we don't go with I here so that I plus 1 doesn't exist. And how can we stop a bit earlier?
Maybe we can put as a condition if I is minus 1, then we return.
Yeah, okay, that's a possible solution. Before doing this, we just check whether I is in the last position, but we can do something simpler. This is wrong. We don't have to go from 0 to len not included. This means from 0 to len not included. we are to go up to len minus 1, not included. If we write here len minus 1, not included, we mean by range, we go from 0 to len minus 1. And we don't go to len minus 2, and we do not go to len minus 1. Remember that if we write a range of 10 means up to 9. Range of len minus 1 means from 0 to len minus 2. So we stopped before. That's another frequent pattern. We don't look at all the sequence, all the positions, but only a portion. And it works. Okay? Well, okay, I want now to let's do something more interesting now. Do you know what is this number?
It's 1 multiplied with 2 multiplied with 3 multiplied with 4 and
Okay.
multiplied with 5.
Yes, and it also has a name,
Factorial.
factorial. So 5 factorial is defined as 1 times 2 times 3 times 4 times 5. That's this number. Can you say in general what is n factorial? When n is a natural number, is a positive integer.
1 or multiplied with 2 dots multiplied with 10.
Well, and by definition, 0 factorial is defined as 1, and 1 factorial is falls in that definition. Is it 1? It is 1 as well. This is the definition of factorial. Well, are we able to compute this value? Obviously, in the math package, there is a factorial function. Okay, let's write it as a comment, as a string, so well, it can stay there. Def fact of n. And I would like to let's try this here. How can we compute this? We need a for loop. Oh, sorry, I didn't say a very important thing. If we write a range of something, let's say range of 5, it means 0, 1, 2, 3. Okay? No, 4. If I write range with 2 parameters, for example, 3, 7, it means this sequence. So from the first item, the first number to the second number not included. And there is also another way. If we write range, for example, 20, 50, 5, what does it mean? It means the sequence 20, 25, 30. Is it okay? 45 and then stop because 50 not included. Okay? So in general, range A, B, and the last parameter is called step, means A is plus step, A is plus 2 step, up to B not included. Okay? So in this way, we can generate a different interval of numbers, not starting from 0. Okay, so what do we do here? We want to multiply many times. So we have, imagine you are doing it by hand again. How do you compute 10 factorial? Imagine you have a pocket calculator. You say 1 times 2, and then you have the result. That result is multiplied by 3, then it is multiplied by 4, and so on, up to n. And we had to go from 0 to n, sorry, from 1 to n included. So which is our range?
0 and n plus 1.
Okay, it's okay for n plus 1. N plus 1 because we had to go up to n. So n plus 1 is not included. So it means n included. And we start from 0.
Yes, 0. Yes.
We start from 0. That's okay. Let's try. And what do we do here? We modify our number. Is it okay? We start from so we
1.
multiply times 2, times 3, times 4, times 5. And sorry, you said 1 here. Obviously,
Yes.
we cannot say 0. If you put 0, the result will always be 0. So we start from 1. And remember, we have to return our result. Otherwise, we don't have any result. So return result. Okay? And then we try print fact of 6. Does it work? Run. 0. Hop. Why? The result is 0.
We have to start from 1.
Okay, that's right. But if we cannot really understand why, what can we do? I don't understand why it doesn't work. If we put here 4, again, 0. I try with 10, again, 0. So, save. We save the file. We call it factorial.py. And we try to debug. That's the key. A small number, 4. Debug, and go ahead. We are defining the function. We call this n is 4. That's okay. So the parameter is correct. N is 4. Go ahead. Result. The variable result is 1. Okay. It works. We can see here. Result is 1. That's okay. Then go ahead. Range 0 and minus 1. And what happens? It happens that I, so 4 plus 1 is 5. This is the range. And what happens here, let's look here, is that I is 0, and now we are multiplying result that was 1 times I that is 0, and so the result is 0. And now we have 0 here. Is it clear? And there is nothing else to do. Now result is 0, and anytime you will multiply by something, we will always have 0. So actually, the for loop is okay because we are doing this many times, but we are always multiplying 0 times something, and the result is 0. 0 times 4. That's correct. We reached 4, but we started from 0. So, which is the change here? Start by 1. Or better, we can also start by 2. Multiplying this multiplication times 1 doesn't have any effect. So we can start from 2. And it should be correct. 24, that's okay. And I remember that the factorial of 10 is about 3 millions, and that's okay. Well, and now I want to show you something very, very powerful. Let's write, do you agree with this definition of factorial? I just have written another factor here. Look at this. What is this part here?
N minus 1 factorial.
Great. So we can change our definition. We can say that n factorial can be written as n minus 1 factorial times n. Okay? Do you all agree?
Yes.
10 factorial is 9 factorial times n. And what is 9 factorial? Is 8 factorial times 9. Okay? Well, but this always is okay if n is at least 1. Let's write in case. And in the other case, in case n is equal to 0, we have to stop this. Let's try to apply this definition. What is 4 factorial? 4 factorial is equal to 4 times 3 factorial. Is it okay? And we know that 3 factorial is equal to 3 times 2 factorial. But we know that 2 factorial is equal to 2 times 1 factorial. And what is 1 factorial? It is 1 times 0 factorial. And we cannot do this forever. We cannot write the 0 factorial is 0 times minus 1 factorial and so on. Otherwise, it will never stop. So there is one case in which we can stop this definition. We say in Italian that it is like a cat that is biting his tail, and it will go up in the same way forever. But in this case, not. It will stop. And what we can say here that this is a recursive definition. We are defining a concept using the same concept. That has no meaning unless we have what is called a base case. And this is the recursive case. And you use these recursive definitions a lot of times. If I write you, we used it also in the primary schools. If I write an expression very long with multiplications, just with numbers, don't think about an equation, just a mathematical expression, numbers, with mathematical operators, arithmetic operators, so multiplications, addition, and so on, and parentheses. How do you evaluate a very long expression? Imagine you always use parentheses. How can you compute the value? You take one operator and you say, okay, my expression is always written like this. It is something times something. Okay, which is the value of this expression? To evaluate an expression, I need to evaluate another expression, then evaluate another expression, and then we make this. So we are saying, in order to evaluate an expression, what do we need is evaluating another expression. How do we evaluate this expression? In the same way, there will be something here inside. It is possible that it is something like this. So how do we evaluate this other expression? Okay, in order to evaluate this expression, we evaluate this expression, and this, and then we make this. We are always doing the same, but sooner or later, we will find a number. And when we find a number, we are done, okay? Well, let's try to apply this definition. We just check whether n is larger than 0. What in this case? Let's start by this. Start from this. What is the result in this case?
1.
This is 1, or better, retard 1. And what in this case?
N times fact of n minus 1.
Perfect. It's written here. Just this. So in order, when somebody calls this function, imagine there are 10 guys. I ask to one of them, give me factorial of 5. He says, okay, it's too large. And it asks to somebody else, give me factorial of 4. And then I will multiply by 5. Okay? And what does the other guy? Okay, I have to compute factorial of 4. It's too large. Somebody can give me factorial of 3, and then I'm done. It works. And it is very nice. Oh, first of all, we see that we are 120 in that score. But what does it happen? Debug. We are defining factor, the fact function. Then we are calling, this is 5, we call fact of 5. Okay, we are stopping here. And look here, we have 5 as a parameter. Okay, the condition is true. Return what? Return 5 times n minus 1 is 4. And we stop here waiting for somebody else computing. Look at the parameter here is 4. So we have a function call with n equal to 5, but this is waiting for this other function call with n equal to 4. And we go ahead in the same manner. This is true. This is 4 times factorial of 3. Okay, stop. And wait for somebody else that is computing factorial of 3. Okay? And it goes in the same way, not forever, but up to the function call in which the parameter is 0. And they all are waiting. Well, I put it here. These all are waiting for the other function call to be finished. And we will have 2 more calls. Factorial 1, okay, we have to compute factorial 1. That's here. They all are waiting for the same. And finally, here the parameter is 1, so we don't still have the final call, because it is 1 times factorial 0, and that's okay. This is another call. All the other calls are still waiting. And what happens here? The function, we have the result. That is 1. And when what you will see now is that all those windows will be closed altogether, because we have not 1 that will be multiplied by 2, that will be multiplied by 3, and so on. So this one will be put here, the result will be put here, then the result will be put somewhere else. It's down there. Okay. Return 1. And they will be all finished. And in some clicks, we will have the result. Okay, so we are finishing all those computations and finally giving the result. Okay? Okay, you will say, why do we need this recursion? This is called the recursive implementation of factorial. And we cannot say whether it's better or not of the first implementation with the for loop. It's a different way of computing that function, or computing that value. And recursive solutions can be very, very, very simple to write. Okay, we will go to recursion in the next lecture. But what I want to propose you now is some exercise. For example, this one. And obviously, in this case, we assume n is a positive integer. How can we write this? First of all, look at some special cases. What about 1? Is it prime or not?
No, 1 is not prime.
Okay, that's just by definition. And since n is a string number, we say that, okay, if n is equal to 1, we return false. Okay. And then go ahead. What can we do here? What is a prime number?
It's a number that divides only by itself and with 1.
Well, okay, so how can we check whether a number is prime? How can you say that
To verify the numbers from 2 to SQRT of n,
okay, square root, that's a faster way. So, but first of all, we need a for loop.
a for loop.
And
Yes.
here a variable, I call div because this is the possible divider. And div in which range, that's what we have to decide now. But what's inside here is if, and we check we have to check this here. And in case yes, what can we say here?
Return false.
Great. What if I write this? That's a very common mistake when I use this false true in a loop. Also, when we were checking whether it is sorted. What if I do this? What happens in this case? We are checking whether the sequence is sorted or not. What does it happen here? The for loop I is, okay, the first position. So in the first loop, what happens? In the first iteration here, that in any case it finishes. Either it finishes with false or finishes with true. So if I write something like this, it will always perform only one iteration, only one loop, one execution of the loop. So it just check whether position 0, position 1, and it says, okay, yes or not. It's wrong. So we only look at the first two elements, and it always stops. It will say true. Okay, this is larger than this. Okay, this is increasing. It's not true. So we cannot say yes here. In the else case, we have to go ahead. So just putting this in the proper position completely changes the meaning of this. Okay? Now, also in this case, if it divides, we can say it is not prime. Otherwise, we cannot say anything. We have to go ahead. And also in this case, we can say true also at the end, only at the end. Okay? And you have to check which is the correct range to put here. So I suggest you n or n minus 1 or n divided by 2, or somebody said s squared t of n. Why? If a number can be divided by some integer number, so if we can say that n is equal to a times b, this is not an assignment, it is mathematics. What can we say about a and b? what I mean by large.
No, they can't be.
If they both are larger than the root of n, the product is larger than n, okay? So if you look at
Or they are,
100,
it's a possibility that they are both equal to n, but usually they're one smaller and one bigger.
we always have a small divider and a big divider. 2 times 50, or it is also 4 times 25. It is also 5 times 20. For each small divider, there is a large divider, and the limit is the root. So we always found pairs of dividers, and one of them must be smaller or equal to root of n. So there is no need to check with large numbers. We can stop at root of n. So this is, but we must be careful because, for example, if we are trying to check whether 49 doesn't have any divider but 7. So we must go up to 7, exactly 7. We cannot stop before. So we must be a bit careful about using root of n. This is the faster way to do it. The fastest way. Okay. And you must write this. That's why, actually, if you decide to go up to n minus 1, that's okay. It's only a bit, not a bit, much slower than this. But we will talk about it next time. And what I ask you now is another return the list of all dividers of n including 1. Don't ask me why. I also want 1. So this is something I can write like this. This is an empty list. Then check with all numbers less than n. So from 1 to n minus 1. And if it is a divider of n, append to divs. Okay? So we have an empty list, and we do something like divs dot append. We already saw this, the divider we found. And at the end, return divs. And what I ask you now, and we will talk a lot about it next time, compute the greatest common divider of A and B. Do not think about factorizing the numbers. That's hard. Factorizing the number is hard, and you don't need to do this. Imagine you have to compute the greatest common divisor among 135, for example. What do? We start trying to, what is the greatest common divider? It's the greatest number, and it is a common divider that divides both A and B. So what do we do? Imagine we have 135. What do? We are not able to factorize into prime factors. It's very hard. Of course, we could do it. It's not so hard. You can try to do it, but we don't need to do it. Which is the first divider you try? We need the greatest. From 1 to
35.
35. But if we try from 1 to 35, okay, they both can be divided by 1. If we are looking for the maximum, the greatest common divider, okay, we are going to the cinema tonight, and I have to look for the parking place closest to the cinema. Do I start looking from the cinema on, or I start looking from infinite going through the cinema to the cinema?
From the cinema.
From the
Obvious.
cinema. The first I try is the best one, okay? We are looking for the maximum. Do we start from 1 or do we start from 35?
From 35.
Okay, great. And stop as soon as, let's say that these are A and B, and we try from the minimum among A and B up to 1, and stop as soon as
The
A.
number.
It must be a divider. This is the remainder. If this is 0 and we really write and means that if this is true and the other one is true, the end is true, and B, remainder div, is both 0, in this case we say, okay, this is the greatest common divider. And you go from the minimum among these two, from 35 in the case of 135, and you go up to 1, 35, 34, 33, and so on. The first number that is both dividing A and dividing B is the greatest common divider. And sooner or later we will find, because in the worst case, we will go up to 1, okay? And you return that. You return D, okay? Okay, it's almost written in Python. It's you only have to write it in Python. Or you can use the list of dividers if you like. Obviously, when you write a function, that function can call another function. There is no problem in writing a function. If I write a function, let's go. Okay, you will find this on the recording. So if we go here, imagine we have to compute the average of a list. What is the average of a list? Return. We already have the total sum. So we can call total sum of the same sequence and can divide by length of sequence. So we are done. We already have written this function. We can use the function and to compute the average. So if you ask for the average, give me a sequence. I ask for the total sum, ask for the length, and give you the result. Okay. Any question? Great. So next time we will write down all these functions together, and we will see a very fast way of computing the greatest common divisor. This is a very important operation in cryptography, and also dealing with prime numbers is very important in cryptography. And we will now we know how to define functions. So we will define functions for solving some more interesting problems. Okay. So goodbye and see you. I'll try to organize another lecture since we have some delay because of the technical problems we had in the previous one. So I will check with the staff whether it can be done. Okay. Goodbye.
Okay, bye. See you next time.
Bye.
See you.
Goodbye.
Bye.
Goodbye.